So this is another question from IIT JEE PYQ. The question is from the Advanced 2023 paper here. Advanced 2023. Okay, so this question is based on the concepts of linear momentum and angular momentum. So here is the question. A thin circular coin of mass 5 gram and radius 4 by 3 centimeter is initially in the horizontal XY plane as shown in the figure. Okay. The coin is tossed up vertically up in the plus z direction by applying an impulse of root under pi by 2 into 10 to power minus 2 Newton second at a distance of 2 by 3 from the center. So at this point we are applying this impulse, and the value of this impulse is what? J is equal to root under pi by 2 multiply 10 to power minus 2 Newton seconds. Okay. At a distance of 2 by 3 from the center. The coin spins about its diameter and moves along the plus z direction. By the time the coin reaches back to its initial position, it completes n rotations. The value of n we have to tell what it is. Okay. And the value of acceleration due to gravity here we have to use g is equal to 10 meter per second square. So when this impulse we are applying at this point, on this coin will be doing two type of motions. One will be the linear motion in the vertical direction, linear motion in vertical direction, right? And second will be the rotational motion about its diameter, rotational motion about its diameter. Okay, so first I will be talking about the linear motion here. What is the linear motion? So this is the coin and it is the center of this coin, and we are applying an impulse at this point J. Okay, let me call it, when this impulse is being applied at this point, the coin will be having a velocity. That velocity of center of mass of the coin is in upward direction. Let me call it VCM. Okay, now coming to the definition of this impulse. What is impulse? That J is equal to force for small interval of time that causes the change in the linear momentum of this object. Okay, so here let me suppose initially this coin was not having any type of motion, so its initial momentum will be equal to 0. And after we have applied this impulse, after applying this impulse, let me call it that linear momentum of those coin is P final, that is equal to what? M into velocity of center of mass of this coin. So by using this equation here, that J will be equal to delta P, that is P final minus P initial. Okay, so P initial is equal to 0, so J will be equal to M into velocity of center of mass, and the value of J is what? That will be equal to root under pi by 2 into 10 to power minus 2. That is equal to, what is the value of mass? That is 5 grams. That means 5 multiply 10 to power minus 3 kilogram into velocity of center of mass. Okay, so this 10 to power minus 2 will be cancelled out here. That will be 10 to power minus 1 only. So here velocity of center of mass we can write, the velocity of center of mass will be equal to root under pi by 2. This 10 to power minus 2 minus 1 if we take in this side, that will be equal to 10 divided by 5. So this is 2 here. So velocity of center of mass will be equal to root under 2 pi meter per second. Okay, so velocity of center of mass we are getting root under 2 pi meter per second. Okay. Now what is the purpose of finding this velocity of center of mass? I will tell you here. Let us suppose this is the ground and this is the coin. I am taking this coin as a particle here, and this particle is being projected in upward direction with an speed of, that speed is equal to √2 meter per second. Okay, and this particle is going like this and it is coming back here. So since gravity is in downward direction, that is G, so we can use the equation of motions under the gravity. Here also velocity will be v if this particle is projected at t is equal to 0 and t is equal to t, sometime this particle is coming back. So we have to find out this value of t. For that, this particle will be in air. Okay. So I will be using the first equation of motion, v is equal to u plus at. So here the value of v, that final velocity is in negative directions, so that will be equal to minus √2 pi. That will be equal to u is in positive direction, √2 pi, and g is in negative direction, so minus g into t. Okay. So here we will be getting the value of t will be equal to twice of √2 pi divided by g, and the value of g we can put here 10, so it will be cancelled by 5. Okay, so the value of time is what? Wait. So the value of time we are getting here, so time will be equal to √2 pi divided by 5 seconds. Okay. So this is the time period for this particle will be in air. Okay, and now we have calculated this time. So now I will be talking about the rotational motion of this coin. So rotational motion of this coin. Rotational motion of this coin. Rotational motion. Okay. So when this is the coin and this is the diameter of this coin, and from the center at a distance of 2/3 centimeter, this is a impulse we are applying. Okay. When you are applying this impulse, this coin starts rotating about this axis, about its diameter in the upward direction. Let me call it, it is the angular velocity omega. Okay. Now since about angular impulse, if I will write, that will be equal to angular impulse that is equal to torque for small interval of time will be equal to change in angular momentum of the object. Okay. So here that tau, if this j I can write as f dot dt from the past equation, that force for small interval of time. And what is the definition of this torque? Tau vector will be equal to r vector cross f vector. Okay, and tau magnitude will be equal to r f sin theta. Okay, so if I write this is the r vector here and this is the f vector here, then this angle will be equal to 90 degree. So this tau I can write here, tau will be equal to r f sin 90. Okay, so that will be equal to r f only, right? Now this angular impulse will be equal to what? Angular impulse will be equal to tau dot that small interval of time dt, that is equal to r f dt delta t. Okay, and this f delta t is what? That is equal to j. From here we can write that angular impulse that is equal to r dot j. Okay, r multiplied by j. So this is our angular impulse, that will be equal to change in angular momentum. Okay, so let me suppose initially the angular momentum of this coin about its diameter is 0. Okay, since there was not any torque acting on this coin and there was not any rotational motion, and after this torque was applied, afterwards the angular momentum, let us suppose L final, that will be equal to I, that moment of inertia about the axis of diameter into omega. Okay, now what is the value of this I, that moment of inertia about its diameter? So this is our coin here and this is its diameter. Then we have to find out what is the moment of inertia about this coin, about its axis. This is omega. Since the axis perpendicular to this coin, about this axis, if I write moment of inertia, that will be equal to mr square by 2. Then by using that perpendicular axis theorem, the value of id, the moment of inertia about the axis of diameter, that will be equal to mr square by 4. Okay. Now writing all the equations here, that j dot r will be equal to what? Angular impulse. Sorry, it is not capital R. It is small r. The distance at which that impulse is applied, that will be equal to L final minus L initial. So L initial is 0. The value of L final is what? id omega. Okay, and jr will be equal to what? The value of id is m r square by 4 into omega. Okay, so now substituting all the values here, the value of j is what? Root under pi by 2 into 10 to power minus 2, and the value of r is 2 by 3 centimeter. In meters it will be 2 by 3 into 10 to power minus 2. That is equal to, the value of m is 5 grams, and in kilograms multiply by 10 to power minus 3, and the value of divided by 4 multiply by the value of r square is what? R is equal to 4 by 3 centimeter. So it will be 16 by 9 multiply by, in meters, that means 10 to power minus 4 into omega. Okay. Now let me cancel all the terms. If these are cancelling, this 10 to power minus 2 will be cancelled by this 10 to power minus 4, and this 3 will be cancelled by this 9, 3, and this 2 will be cancelled from here. That will be equal to what? 8. Okay. Now let me keep all the terms like here. So omega will be equal to what? Root under pi by 2 multiply by this 4 multiply 3, and this 10 to power minus 3 will come here downward, and in upward it will, I can write here 1000 divided by this 8 multiply by this 5 will be equal to 40. Okay, so if I cancel all the terms here, this 4 will be cancelled, here will be 25. Okay, so value of omega will be equal to root under pi by 2, 4 multiply 3, 3 multiply 25, that is equal to 75. This 4 I will be keeping here, this will be 75. This root 2 we can cancel from this 4, that will be equal to 2 root 2. Okay, so the value of omega we are getting here, that is equal to 2 root 2 pi multiply 75 radian per second. Okay, so this is the value of omega, that angular velocity this coil will start rotating from this, about this axis of diameter. Okay, and the value of time we already calculated, that the time for that particle will be in air, that is what? Time will be equal to root 2 pi divided by 5 seconds. So for this time, root 2 pi divided by 5 seconds, for this time this particle will be in air. Okay, since we know that angular displacement will be equal to what? Theta is equal to omega into t. Okay, so this is the angular displacement this particle, this coin will travel in this time period. Okay, and the value of this theta will be, we'll write 2 pi into n number of rotations, that will be equal to omega into t. Okay, so now we have to find out the value of this n only. So n will be equal to omega t divided by 2 pi. Okay, So let me substitute all the values here. So n will be equal to omega is what? 2 root 2 pi multiply 75 into time period is what? Root 2 pi divided by 5. Okay, and divided by 2 pi. Okay, so this root 2 pi will be cancelled by this 2 pi, and this 5 will be cancelled from here, that will be equal to 15. So the value of n we are getting here 15 multiplied to 30. Okay, that means n is equal to 30. So this coin will be doing 30 number of rotations before coming to its original position again. Okay, so this is the process we used here to solve this question and the concepts. Okay, the correct answer is n is equal